In this video, we will talk about applications of the unit circle. Find exactly the possible values of cosine of theta for sine of theta equals to 2 over 3. Illustrate your answers. Sine is positive on first and second quadrant according to the rule of all students take calculus. So when we plot this, we have theta is positive on first and second quadrants, this being theta and this being theta. Sine, as we all know, is opposite over hypotenuse. So if we drop it down perpendicular to the x-axis, because SOHCAHTOA only works on a right triangle, we have opposite over hypotenuse. Same here, opposite over hypotenuse. We need to find this x using a Pythagorean theorem. We can say x squared plus 2 squared, which is 4, is equal to 3 squared, which is 9. Therefore, x squared is equal to 5. Therefore, taking the square root on both sides, we get x is equal to, don't forget, plus minus square root of 5. This makes sense because this side will be the positive square root of 5, and this side will be negative square root of 5. Once we have that, cosine of theta is easy. Cosine of theta is equal to adjacent over hypotenuse. So adjacent is a root 5 over 3, and on the left side, negative root 5 over 3. So we can say cosine of theta is equal to plus minus square root of 5 over 3. Another way to look at this problem is using a Pythagorean identity that we looked at in the last video. Pythagorean identity states that cosine squared x plus sine squared x is equal to 1. We know sine of theta is equal to 2 over 3. So 2 over 3 squared will make it 4 over 9 is equal to 1. And cosine squared x is something that we don't know. Subtracting the 4 over 9 on both sides, we get cosine squared x is equal to 5 over 9. Taking the square root on both sides, we get cosine of x is equal to plus minus square root of 5 over 9, which is plus minus root 5 over root 9. But we know that square root of 9 is equal to 3. So plus minus 5 over 3. In both cases, the answers come out to be the same, but you should be able to do it in both ways. If sine of theta is equal to negative 3 over 4, and theta is in between pi and 3 pi over 2, find cosine of theta and tangent of theta. Between pi and 3 pi over 2 is on the third quadrant, because this is pi, this is 3 pi over 2. So the theta is the one that forms with the x-axis, so this will be the theta. So if we use the first method, form the 90 degrees, sine is opposite over hypotenuse, so this will be negative 3 because it's below the x-axis, and hypotenuse will be 4. So then what's the value of x? X squared plus negative 3 squared, which is 9, is equal to 16. So x squared is equal to 16 minus 9, which is 7. So x will be plus minus root 7. But in this case, we're looking at only the third quadrant, so the x value must be just negative root 7. So once we know that x is equal to negative root 7, we can say cosine of theta is adjacent over hypotenuse, so that makes it negative square root of 7 over hypotenuse 4. And tangent of theta will be opposite over adjacent, so negative 3 over negative square root of 7. So negative over negative will make it positive, so you can leave it as a 3 over square root of 7. You could rationalize this fraction, but you may also leave it as it is. If we were to use the second method, we would say cosine squared plus sine squared is equal to 1. We're given a sine of theta, so we have negative 3 over 4 squared, which makes it positive 9 over 16. So cosine squared plus 9 over 16 is equal to 1. Cosine squared, subtract the negative 9, subtract 9 over 16 on both sides, so we get 7 over 16. Then take the square root on both sides, so we get c is equal to square root of plus minus square root of 7 over 16. Since we're only looking at the third quadrant, cosine, the x value must be negative, so the only answer will be negative square root of 7 over square root of 16, which is 4. So in both cases, we get the same answer of the cosine of theta, and then tangent of theta will just be either opposite over adjacent, or you can also look at it as sine theta over cosine theta. In both cases, you should be getting the answer of positive 3 over square root of 7. If tangent of theta is equal to negative 2 and theta is in between 3 pi over 2 and 2 pi, find sine of theta and cosine of theta, give exact answers. First, we need to figure out which quadrant it's located at. 3 pi over 2 and 2 pi, in between those two, will be on the fourth quadrant. Theta, again, is the one that forms the angle with the x-axis. So we know tangent of theta is equal to negative 2. Tangent is opposite over adjacent. So tangent of theta, which is equal to negative 2, we know this is opposite over adjacent. So if we put this over 1, we can say tangent is opposite. This has to be negative 2 over adjacent. This has to be 1. So can we find the hypotenuse? Using a Pythagorean theorem, we can say 1 plus 4 is equal to x squared. Therefore, x is equal to, in this case, root 5. So sine of theta is opposite over hypotenuse, so that will be negative 2 over square root of 5. Cosine of theta is equal to adjacent over hypotenuse, so it'll be 1 over square root of 5. For theta in radians, sine pi minus theta is equal to sine of theta. Cosine pi minus theta is equal to negative cosine of theta. And cosine 2 pi minus theta is equal to cosine of theta. Let's look at the first two. Given an angle theta, pi minus theta will be 180 degrees minus that same exact angle. So we're going to be on the second quadrant. So on both cases, this x and y on the first quadrant will now become negative x and y. So as you can see, the cosine, the y value, remains the same. Cosine, which is the x value, will now become negative. However, if we subtract the cosine from 2 pi minus theta, so 2 pi is a 360 degrees minus that same angle, we're going to be left on the fourth quadrant. So that angle now will be, starting over here, 2 pi minus theta. You could also look at it this as another negative theta angle. In this case, the x values will remain the same and y values will be now negative. So the third one comes from 2 pi minus theta, the x-coordinates remain the same. If we had the sine of 2 pi minus theta, this will become negative sine of theta. Using a calculator, find two angles theta on a unit circle between the angles 0 to 2 pi. Since we are talking about the angles in radians, make sure to go to your calculator and see if your mode is in radian. Cosine of theta is equal to 1 over 3. So cosine of some kind of angle returns the value of 1 over 3. So if we find the inverse of 1 over 3, we'll get an angle. In order to do that, you need to go to second cosine, which has a sign of cosine of that negative 1, and plug in the value of 1 over 3. It returns the value of 1.23, and so forth. So cosine is positive. Where is cosine positive? Cosine is positive. All students take calculus. It's positive on first and fourth quadrant. It's saying that this angle is 1.23. How can we find this angle right over here? It will be 2 pi minus 1 over 23. Because this angle over here is 1.23, this angle is exactly the same as 1.23. Therefore, if I subtract it from 360 degrees, which is a 2 pi minus 1.23 will return the value of 5.05. So the two angles are going to be 1.23 and 5.05. Second question, sine of theta is equal to 3 over 4. So use the second sign to find the inverse of sine at 3 over 4, which returns the value of 0.848. This number is positive, so look at where is sine positive. All students take calculus. So it's positive on the first and second quadrant. This angle, again, is 0.848. And we know this angle should be the same, 0.848. So the question remains, how do we find this black angle? In order to find the second one, we will need to subtract from pi. That 180 degrees minus 0.848 angle, which returns the value of 2.29. So two angles are going to be 2.29 and 0.848. Lastly, we have tangent of theta is equal to 2. Tangent of theta, so go to inverse of tangent, sometimes we say it as an arctangent of 2, returns the value of theta, in this case 1.11. Now look at where is tangent positive. All students take calculus, so this is 1.11, that again is a 1.11. So in order to find this blue angle, we will need to add pi onto 1.11. So pi plus 1.11, which is about 4.25. So the two angles are going to be 4.25 and 1.11. I suggest you should pause this video and try the problems on your own. Find two angles theta on the unit circle with theta between 0 and 2 pi. First problem, sine of theta is equal to negative 0.4. Sine is negative on all students take calculus. So it's negative on the third and fourth quadrants. by putting arc sine on your calculator, or inverse sine, we get a value of negative 0.412. This negative tells us that it has to be a counterclockwise rotation. So the negative 0.412 refers to this angle. Then what should be the same on here? So on both cases, it's going to be 0.412. Let's look at the first angle. It's pi more than 0.412. So for the first one, we need to add pi. Pi plus 0.412, which returns the value of 3.55. For the second angle, we need to find this black angle. We already know this is a 0.412. So for the second one, we need to subtract from 2 pi. 2 pi minus 0.412, which then returns the value of 5.87. For the second problem, we have cosine of theta is equal to negative 2 over 3. Cosine is negative on all students take calculus. So it's negative on second and third. By plugging the arc cosine of negative 2 over 3, we get a value of 2.3. So then that 2.3, since it's positive, refers to the value over here. So that's going to be our first angle. For the second angle, 2.3, if we were to go to this direction, it'll be negative 2.3. So in order to find x, starting at the x-axis, go around counterclockwise, we have to subtract from 2 pi. So the second one will be 2 pi minus 2.3, which then returns the value of 3.98. Lastly, we have tangent of theta is negative 1 over 3. Tangent is negative on the second and the fourth quadrant. By plugging arctangent of negative 1 over 3, we get a value of negative 0.322. Again, since the angle is negative, it's going to clockwise rotation. So that is 0.322. Another angle that's exactly the same is over here. That's 0.322. So in order to find the first angle, we need to subtract from pi. Pi minus 0.322 will return this black angle. So first one will be pi minus 0.322, which then returns the value of 2.82. For the second angle, we now need to find all the way around up until here. So that's going to be 2 pi minus this angle of 0.322. So we get a value of 5.96.